I'm Vaibhav Advisori. I have done the data reporting part and the SVM model training. In here, we have imported the required packages, NumPy, Pandas, Seaborn, Matplotlib, Matplotlib for the data visualization part, for the data reporting part, Pandas, NumPy, and the Seaborn. Seaborn. In here, I have connected to the single drive. In here, I have imported the data set. This is the how our OKID data set looks. There is a flower image, number of flowers, number of leaves, and the date, time, location, and shop name, and the age. Age gap peak. Age gap peak is our target variable. 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 In here, I see the value count of the age gap peak because it is our main target variable. The variable that adults have 321, young 57, child 52, mature 46. But this way in here have the flower names value count I have three. See now I'm going now here I have done the categorical variable to convert to the number because machine learning model can train with only numerical values. So we need to every value convert to the numerical value before to give them. Um, in here, I have added another age gap numerical columns. After converting, you can see that column in here in the adults is got the phone number, mature is got the phone number, young Muslim, like this way, and there is the other column where we are not good relationship with our age prediction. So I have dropped those columns, column and age gap we call is the target variable, but it's no need now because I have another column named age gap numerical. That's why I drop column that here. Here after that I have visualized the correction matrix as a heat map. And heat map, this is the heat map. Um, uh, in here there is have a single null value. In here I have drop and look at there is have any null value. You can see there is every column is zero. Means there is no null value. No. In here I have separate the data set for the x variable. In here, in these are the x variable, these are the y variable. Y variable is our target variable. These are our yeah, the variable we are going to change. If that's my table. In here I print the X shape and the Y shape. Y shape, Y shape. In here also look at the null. In here Y is value count is look like you can see there is a 5. Within the HCAP 5 category have the 321, 3 have the 57, 2 have the 52. This is unbalanced data sets. So before we train, we need to this data set need to balance. Otherwise, it will train wrongly. In here, I have used the imbalance over simple SMOTE package for the data set balance. In here, then now you can see after balancing every target variable have the equal number of columns, equal number of rows. So I have done up to this point, and the SVM model training.
Hello, I am Dilishan Nompi. For our ML assignment, we are going to develop four algorithms. We selected four algorithms as KNN, logistic regression, decision tree, and SVC. And we selected dataset as OKID age predictor. We gathered those data from the field because this is our final year project part. Here you can see our dataset. First, we are here you can see our parameter values, number of flowers, leaves, fruits, and number of stems. According to that, we are going to predict age gap of the orchid plant. First, we are going to import necessary libraries and we are going to connect to database. Here you can see our CSV file connection. Then we are going to retrieve our dataset preview. here you can see dataset preview, and according to the dataset, we are going to take the actual number of adults, young child, mature baby, orchid plant count, and yeah, after that, before developing algorithms, uh, we are going to do some data pre-processing part. Here you can see we are going to print the confusion matrix for the features. After that, this is the data pre-processing part. We are going to remove null values. After that, we are going to clean the data set for our pre-processing task. And here you can see before removal and after removal, we are going to do some changes of our dataset. This is the results of the data pre-processing part. And after that, for my part, I am going to develop the decision tree model, and I am going to show the confusion metric and accuracy loss. And here, mm, first, we are going to, here you can see we are going to loop all four algorithms. First, we are going to take the algorithm and we are going to split it, training and testing. Here you can see we are going to split it. After that, this is the testing size we mentioned as 0.2. After that, we are going to mention the module name, accuracy, and the confusion metric. Here you can see according to this print statement, we are going to print the model and the accuracy. And as the first one, here you can see the results. For my one here, you can see this is the decision tree, and accuracy is 0.96. So this is good accuracy for decision tree model, and this is the confusion metric of decision tree, and you can see other models as well. According to the this algorithm, here we are going to predict the best model out of these four. Here you can see best model mentioned as decision tree and the accuracy as 0.96, and you can see the confusion metric also here like this. So we are going to predict the best model out of these four as a decision tree model. So those are the things we are going to cover up. We selected a good data set from the field, and we developed four models, and my part is decision tree. And before implementing decision tree, we are going to do some data pre-processing part as well. Here you can see we use some commenting for maintain best code quality. So those are the main things that I have did in my part. Thank you.
So in machine learning assignment project, I choose logistic regression as my component. So I'll explain how it works. So firstly, uh, first we import necessary Python libraries for data manipulation, visualization, and machine learning. We especially import the logistic regression from scikit-learn, which is the classification algorithm used in this project. So you can see how I import the relevant libraries here, as well as as a second step, here we load the ORCID dataset, which include features like number of flowers, leaves, stems, and root area, all important indicators of the plant maturity. Each sample belongs to one of the growth stages such as baby, young, mature, or adult. You can see the dataset also in this table. Next, to prepare for the training, we convert the target variable age gap week into numeric format. This step is necessary because machine learning models work with numbers, not the text. So you can see how I implement this in here. As well as we remove the non-essential columns like date and shop name, focusing only on measurable physical attributes that influence the ORCID age. we separate the input features from the target label. X contains the attributes we'll use for prediction, and Y contains the numeric age class. After that, we split the dataset into 80% for training data and the 20% for testing data to evaluate the model performance later. As well as this is how we import relevant libraries, how we use that machine learning algorithms. We use 4 algorithms, and my part is logistic regression. We apply standardizations so that all features are on a similar scale. This helps logistic regression coverage faster and improves accuracy. Here we train the logistic regression model. This algorithm works by applying a sigmoid function to predict the probability that sample belongs to a certain class. As a small explanation, logistic regression is a classification algorithm that models the relationship between the input features and the class membership. In binary cases, it finds the best decision boundary to the separate two classes. In multi-class problem, we use the we use a one versus rest approach, meaning one model is trained per class. Now we move to the prediction. Once trained the model is used to predict the age group on the test data. These are the final prediction made by our classifier. And finally, we evaluate the performance using confusion matrix. You can see those on this Jupyter notebook, classification report, and accuracy score as well. This matrix helps us to understand how accurately the model distinguishes between different ORCID age groups. Finally, in conclusion, logistic regression gave us fast, in interpretable and reasonable accurate model for the predicting ORCID growth stage. Its simplicity and performance make it great starting point for structured data like this. So thank you.
Hello, I am here at HMKCB. For the ML assignment, we have selected 4 algorithms. First, we need to import the necessary libraries as shown here. Then we have connected it to the Google Drive and imported the dataset from here. So this is the dataset preview, and you can see the number of counts of features on the datasets here, and For the before training the model, we need to pre-process the data. So these are the correlation metrics for the each feature, the heat map. So then we need to select the features to divide as X and Y. So you can see here we have separated the features for the X and to the Y. Then we need to split the training and credit dataset as training and testing um, to maintain and to ensure the accuracy. In here, we are going to calculate the accuracy and predict the model name, the accuracy, and the confusion metrics. For that, I have done the KNN model. So those are the models that we have selected so far: the logic regression, decision tree, the KNN, and FPN. So this is the accuracy graph of my model, the KNN model. From those 4 algorithms, so those models we have selected the best of them out of 4. So that was the decision tree. By considering the accuracy levels, we have selected the best model out of those 4. So this is the accuracy graph of the base model we have selected, the decision tree classifier. So you can see the predicted output. So finally, you can see the predicted final output by considering the dataset and with the highest accuracy model that we have trained.